Hi students, so now I will discuss what electromagnetic spectrum is, and before that what electromagnetic radiation is, which is, as I told you, that it is unique to every atom, so it is an identification mark for every atom of element. So let's begin. Hi, now we'll move on to electromagnetic radiations and spectrum. So first of all, we'll see what exactly is meant by the electromagnetic radiations, what are their properties. So if you have, say, suppose X-rays, gamma rays, then why they are called as electromagnetic radiations? Because they can be produced by charged body, okay, in either a magnetic field or an electric field. So by electromagnetic radiation, I generally mean that the radiations which are produced by a charged body. Charged body is very, very important here in the presence of any field. And the very unique characteristic is that they do not require any medium. They never require any medium for their propagation. It's like this, the transverse waves. This is electric field, this is magnetic field, and this is a direction. So all these three are perpendicular to each other. All these three are perpendicular to each other. Means you can assume it as a X, Y, and Z axis. 3D. So by spectrum, what does we mean? This electromagnetic spectrum is actually the order of increasing wavelength or frequency, or decreasing wavelength or frequency. Like this way. This is of visible light. So that's why it is known as visible spectrum. Visible spectrum of natural light. Now, this is at increasing wavelength. That means it is at decreasing frequency, because your lambda and frequency is inversely proportional. Okay, lambda and frequency is your inversely proportional. So how do atoms, they have this pattern of spectrum? The reason is whenever they are excited, they emit light. Okay, and this corresponding light gives us the spectrum, electromagnetic spectrum, which is very unique to every atom. And with this series of light, we get either colored lines or dark lines there. Okay, so I will tell you in very short, in very few time, that there are two types, continuous and line spectrum. Even dark or bright is here also said. So what exactly are those things? Obviously, these set of spectral lines are unique. It's like fingerprinting. That's why no two elements emit the same spectral lines. Okay. So here comes the first type, absorption spectrum. So what is this absorption spectrum? It has dark band of lights. Whenever my radiation is passed through the material. So the bands which corresponds to the energy absorbed by the material. Suppose you are providing energy, okay, and that energy is getting absorbed, and then I am getting a pattern of light. Pattern of light means I am getting a spectrum. So that is known as absorption spectrum. And we have emission spectrum. Again, if energy is absorbed by material is emitted, then we get an emitted spectrum. That is called emission spectrum. Okay, it actually gets excited to a higher state first, and then while returning down the ground state, okay, like for example, if it is excited from n is equal to 1 to n is equal to 5, means the first to the fifth orbit, and then again from n is equal to 5 to n is equal to 1, it is coming back, then what it will do? Then it will emit your radiations of light, the spectrum of light. That is known as emission spectrum, basically. Now what are the types of emission spectrum? Let's discuss. The one is continuous, means you have continuously, you will be able to see continuous lines, okay, just on the sidewise to each other. So adjacent to each other. Like for example, the natural sunlight or the bulb, wave geode, okay, which gets split up when you pass the light through prism, like a rainbow. So these are what continuous spectrum. Next we have line spectra. In case of line spectra, what happens? I get a line with some gap, okay, another line with some gap, like this way. In this way I get a line spectra. It's like this. For example, you are having, say this is a bulb source, right? You pass it through the prism, you get a continuous spectra, okay? This is a hot gas, you pass through the prism, you will get an emission spectra. Here you can see the lines also, right? The lines. And if you get a bulb and a cold gas, and then you pass through the prism, then you will get the absorption spectra, okay? In case of absorption spectra, you will be able to see dark lines, dark bands, okay? So that's why here you can see the dark lines. Next, the very special case which is studied is your hydrogen, okay? Because it is considered as the most simplest atom, okay, with no neutrons first of all. Sorry. So in case of hydrogen also, we pass it through the electric discharge, okay, and then we observe the lines, which is known as atomic spectra of hydrogen, okay. These can be seen on a photographic film, and they've been named by scientists like Lehman, Balmer, Fund, series, on the basis of series they obtained. So we'll see that, okay. You can see here, it's written 6 series of lines discovered by these scientists, okay. So to honor them, they have been given that series of lines, spectra of hydrogen, like Balmer, Bastian, Lehman, Brackett, Fund and Humphrey series, okay. And the formula for calculating the wave number, okay, or wavelength, this V bar is your wave number, okay. This is known as wave number. So it tells you the number of waves, and 1 by lambda is your wavelength. So that is equal to R is a Rydberg constant, into 1 by n square minus n1 square minus 1 by n2 square, where n1 n2 are what? n1 n2 are your orbit number. Okay, Rydberg constant value is 109678 per centimeter. So what actually is mean by that series? The spectra is like, if I'm saying Lehman series, okay, so this is my n is equal to 1, this is my n is equal to 2, this is my n is equal to 3, this is my n is equal to 4, and n is equal to 5. So the number of lines, okay, which can come to n is equal to 1, fine, that is given by Lehman series, okay. Similarly, the number of lines which can reach up to n is equal to 2, from a higher state to that lower state. So that is your Balmer series. Again, from Bastian series, okay, what we can just interpret, any number of lines, the number of lines from a high state to the n is equal to 3 state. So this can be the chart. For Lehman, my n1 value should be 1, n2 can be anything, okay, any integral up to infinity also, okay. So, and that spectral lines is observed in ultraviolet region. Similarly, Balmer, it is visible region. Bastian, infrared. Brackett, infrared. Fund, infrared. Then you have Humphrey series also, in which my n1 will be equal to 6. Let me write it here. It's not written here. The Humphrey, for this, my n1 that is equal to 6, and it can be 7, 8, etc. That is your far infrared region, okay, beyond the red as well, infrared. So this is a note for you guys that all the lines in this visible region are of Balmer series, right? Visible series, as you all can see, that for visible series, I have my Balmer series. For visible spectral lines, I mean, okay? What I have? I have my Balmer series. But the reverse is not true, guys. Means all the Balmer series lines will not fall in the visible region, okay? For example, even some lines in past chain bracket, okay, they can fall in visible region, some lines, but they are not in the Balmer series. So the reverse is never true. So the pattern of lines in the atomic spectrum is the characteristic of hydrogen. It's not only of hydrogen, the pattern of lines is for any atom, okay, but this analysis is done for hydrogen atom.
So students, we have seen that what was electromagnetic radiation and spectrum. We also saw about hydrogen spectrum, the whole series, Lehman, Balmer, Paschen, Fund, Humphrey, everything, bracket also. So these are all are what they are very unique to every element. Right now, the analysis which I gave you was for hydrogen case, but analysis for many different atoms has been already made. And this was all about orbital theory, means I am talking electron as a particle. But now electron can also be a wave. So we'll talk of duality nature of electron in the next part, which is dual nature of matter, and one more effect which you will understand, that is photoelectric effect. So stay tuned with me for that.